All right, get your homework out.
Are you good? The girls get pretty good. I do like that. No.
Okay. Nelly, shut the hell up. All right, so get your homework out. Claire, what's your homework? All right, so first question. I'm not going over. Just make sure that you guys understand. But this kinematic will be on the AP exam again, on BC exam. So you have to be.
What is E?
Velocity is equal to 0. Yeah, I take it. I take a derivative. Why you guys are so late?
We were at college and career. She said like use the pass. Like she did a smart pass. Yeah. I have to go back to it. So maybe come here first. I really do have to go back. I have questions.
Yeah.
She told me to text her once I get here. So
Okay, that's your grade.
Velocity increasing. I literally saw right later when it
Okay, shh. Guys, there's a difference between velocities increasing and the speed is increasing. Speed is increasing, you have to consider what Joshua's demonstration yesterday. Now, when the velocity is increasing, you just take a derivative and look at velocity when it's positive, when it's negative. And that's it. Yeah. So number 1 is E. Number 2 is E also. That's the best answer because you take a derivative. Yeah.
One is keeping a critical point when the slope of velocity is positive. When the slope of velocity is negative, then it's so if the slope of velocity is positive, then it's the slope of velocity is acceleration.
Okay. Shh. Number 3 is a lot of people make mistake. It's not the difference of a velocity. It's the difference of a positions. So you have to plug in the position of 3 pi over 2 and then 0. And plug in 3 pi over 2 minus 0. And you should get your answer to be square root 2 over pi. Okay, maximum acceleration. This one's kind of tricky. This one you have to do the absolute max. So what happened is you had to take second derivative to get acceleration. You had to take one more derivative to Brendan. You guys, you need to put your phone away. You guys have to take a derivative again, and then to find out where is a critical point at acceleration. So it's at 1. And then you have to plug in, you have to do the table. You have to do the 0, 1, and 3. And you compare which one's the highest. So therefore, the highest is 36. I don't know if you did this one right, but this is a very good question.
Why did you write C next to it?
What? Don't worry about that. Worry about the answer.
Are you sure?
Yeah. Okay, so maximum acceleration, guys. Guys, either let me talk or you talk. If you want to talk, go ahead. I don't care. Maximum acceleration, basically you take a derivative to get to acceleration, which is 2 derivative. And then you have to take one more derivative to find out the critical numbers. And then you do critical number and the endpoint comparison. Supposedly you're supposed to do a table and you plug in a to the 0, a to the 3, and a to the 1. Is if you plug in a to the 1, then you would get negative 12. So you will not get the maximum acceleration. So if you plug in 3, it's going to give you a maximum acceleration because 3 is going to give you 36. So in a sense, you should do a table justification. That's the best. Okay, so even though some of those questions that you've done it before, you might not remember. So question 5, just slope between 2 points. Bennett, shut the hell up. Okay.
Bad boy.
All right. I apologize. For 5, it's B is 12.5. Just take a slope between those 2 points, and you get 12.5. Average acceleration is the changing velocity over changing time. Make sure that you understand that changing velocity of changing time is acceleration. So in this case, E. Question 7. You had to deal with chain rule. Be careful when you take a derivative. Said they want a second derivative, so if you take a first derivative, it's going to get 2 plus pi cosine of pi t. If you take a second derivative, there's a chain rule. You're going to accumulate the pi in the front, become pi squared. And then you're going to plug in 3 over 2, so it's going to give you negative times negative is positive pi squared. That's 7. Any question about first 7 questions? Now, when you get to 8, you have to do 2 number line tests. So you have to do the first number line test because it's talking about speed. So speed, you have to do the comparison between the speed is positive and speed is negative. So in this case, it will be 1 to 2 and greater than 3. Usually I line the number line exactly proportional one on top of each other, so it can easy to read the plus sign and minus sign. So that's just something I would do. They didn't line up like exactly. I'll write like if it's 1 on 1 and the 1 on slope, 1 on acceleration, I'll line them exactly correctly, so I can check the plus and minus sign. That's gonna, like, if you build a good habit, then you can solve this problem a lot quicker. Hayden, does that make sense? Okay, you do 2 number line tests. So first of all, I did derivative, and I got t equal to 3 and t equal to 1. So I'm gonna do 2 number line tests over there. So I will do another number line underneath, and I'll take a second derivative, so t equal to 2. So 2 is like this, and this is a negative and this is positive. Do you see that there's 2 negative signs here? That's speed up. So it's 1 to 2. So 1 to 2 is speed up. And from 3 and on, it's both positive. But from 2 to 3 is 1 negative, 1 positive. So that's not right. Okay. Question 9. Same thing. You want to take a second derivative and then plug in pi. Well, it just make sure you do a chain rule. A lot of times, the chain rule is always the one that hits you. So it's negative pi over 2. Question 10 is going to be equal to 36. So it's actually 0 and 4. So you have to take a second derivative, plug in a of t is equal to 36, and you solve for it, you're gonna get t equal to 0, t equal to 34. Acceleration first particle when acceleration equal to 0, so you take a second derivative, set equal to 0, you find out t equal to 3. Then you're gonna plug in 3 into the velocity equation, and you're gonna get an answer. Number 12, same thing. Acceleration first equal to 0, take a second derivative, set equal to 0. It happened at t equal to 1, and plug in 1 into the velocity equation. So basically just knowing how to maneuver that. 13 is gonna be t equal to 2 over 3, and t equal to 2 because the velocity is decreasing there. And 14 is the question's bad. Okay, you guys have to go. Watch your video.
What are we like learning?
Chinese Wi-Fi problem.
Chinese Wi-Fi problem?
Second on the text, or is it just extra knowledge?
No, extra knowledge plus I think
What you think? What?
and but also fundamental theorem of calculus, which is
I think I have to go as well.
all right. So let's go to look at here. So this is a Chinese Wi-Fi problem. Now the cool thing is this, I'm gonna talk about this in a bit because I think like a lot of you guys don't understand that this thing is very important. If you ever integrate something, if this f of x is odd functions between negative a to a, what do you think the answer is going to be? Why do you think it's 0? They mirror to each other, they are symmetry to origin. If they symmetry to origin, if like this area here and this area here are offset each other, it's going to give you a 0. Very, very important thing. Now, if it's even from negative a to a of f of x dx, that will be 2 times 0 to a of f of x dx. Now, why is that? Because if you have a even function, then it's going to be like absolute value function, right? This area here and this area here are the same, but if you do it from 0 to a, it's going to be positive. Now, we're going to go back and look at this questions here, the Chinese Wi-Fi problem. Now, put in mind, this is in a Nanjing University. Nanjing University, their cafeteria. In the cafeteria, in Chinese cafeteria, it's not like the school lunch here, it's garbage. But in like a university in China, if you ever eat in the cafeteria in lunch, it's actually fantastic. They have really, really good food. By the way, do you guys know where Nanjing is?
Yes.
Have you heard about Nanjing before?
Yes.
When's the last time you heard about Nanjing? Huh? They went to massacre all the people in Nanjing, and they raped all the women. A Japanese soldier went into every house and raped all the women. Not only that, there was actually a general take a samurai sword, like going out and just chop off people's head for fun. So he cut off 103 head by himself. Like he just take a knife, samurai sword, and just do it for fun. They have a competition between all the generals, and they will go out and chop off people's head, and those people have nothing to fight back. And so it's actually like one of the worst place. In Japan, actually did a lot of like horrible thing to Chinese people back then.
Well, they had a bunch of experimental like crap.
Yeah, they inject the virus into them.
Yeah, for
They froze people's hand. And they smash it with the hammer. And just for fun.
They should have do things on the hot dogs.
Yeah, so it's a crazy stuff that they did in like for me, like I think a lot of people say, so yeah, Jewish had a really bad, Yeah, they did. But Chinese has worse actually to compare to the apple to apple. From one massacre to the other massacre, that Chinese lost way more population compared to what Jewish did, and I'm not saying like one thing is better than the other. No, it's like they both are horrible. But Chinese people never did complain about it as much. So anyway, probably gonna get myself canceled. So let's talk about this problem. All right, so Alan did it. Alan almost did it. -2 and 2. So we have this question on the board. And basically in Nanjing University in cafeteria, if you want to use Wi-Fi, you have to solve this problem. Basically, they say first 8 digit of this number is the password. That's what exactly it says. I can show you. I can literally show you because Jenny can read Chinese. This is actually the cafeteria name, and there's like this says password. It says using the first 8 digits. What?
I still don't know the 8 digits for the answer.
What'd you say?
For the answer, I still don't know what the password is.
Okay. Anyway, so what happened in this question? You don't need to know how to do definite integral. You just need to know the geometric understanding. So if I were to take this and I distribute to both, right? So that will be x cubed cosine of x over 2 times 4 minus x squared. And then plus 1/2 square root of 4 minus x squared dx. And then you just had to integrate between -2 to 2. Well, the tricky thing is from -2 to 2. Because if I look at the first function and imagine that's f of x equal to x cubed cosine of x over 2 square root of 4 minus x squared, we're going to see if this is even or odd. So if I plug in -x, that's going to be -x to the cube, right? And cosine of -x, because cosine graph is symmetry from left to right. So therefore, it still end up to be x over 2, because it doesn't matter if you plug in -x, the outcome is going to be -x. The reason being is cosine graph looks like this. Oops, my bad. Like this. So if this value is going to be the same, regardless what happened. Even this value and this value is going to be the same, because the left and right are symmetry. So if you plug in -x, it's going to come out to be cosine of x over 2 still. And this one's going to be 4 minus -x squared. So that's going to go to -x to the cube cosine of x over 2 square root 4 minus x squared. If you figure out that's actually negative f of x, so this is actually an odd function. So the whole thing goes 0. The whole thing goes 0 because it's an odd function. Now all I had to do is focus this, which is we know how to do that because Joshua says yesterday that is a semicircle.
Wait, why is that x over 2 in the middle?
Can you go to the theorem first?
Say cosine x.
Huh?
He has a function.
No, in x. Yeah, but it's like
Okay, but like it might have been I didn't know the theorem.
So this becomes a circle, a semicircle between -2 to 2. So this is a 2 pi. So it'll be 1/2 times 2 pi. So the answer is pi, which is 3.141569.
I gotta go to the proper shit.
All right, bye.
I'm going.
You too.
We're just doing fundamental theorem calculus.
Yeah, in the second part of fundamental theorem calculus. Like part 2, you take an integration and take a derivative. We did that last year.
Okay.
And guess what? So what's the moral of this question? Like, what is the point of this question? The point of this question is a lot of time people need to understand calculus is based on a lot of discipline, like algebra, but more importantly, it's also geometric understanding of math. A lot of you guys don't have, you guys know how to take integral and you know how to plug in a value. That's only algebra perspective, but you're not looking at it. What is the geometric perspective is? I mean, understand the graphing is actually very valuable. Like I said, a couple years ago, I had Emma Bradford come into my room, and the kid is brilliant. He never studied anything, got like 5 on like physics, AP physics, and it's just a brilliant kid. But he come into my room. I said, "So okay, do you know how to do square integration of 4 minus x squared, square root of that between -2 to 2?" And the guy cannot do it. What happened is because if you actually do it algebraically, you need a calculus 2 to do it. And like back then, he take A, B, and BC at the same time, and he didn't get to calculus 2 yet. And even if he done it that way, it would take about 20 minutes. Rather than this way, it only takes 10 seconds. So that's the thing about it. All right, Aiden, this part as I'm just teaching you is what's the fundamental theorem of calculus. Basically, if you integration of some type of f of x dx and between some boundary, let's say between a to b, and when you integrate the f of x, the notation difference. So it's like if you integrate like Mario, like a small Mario, when you eat a mushroom becomes big Mario, pretty much like that. So it becomes the capital F of x between b and a. And then what you're gonna do is you're gonna subtract the difference. So f of b minus f of a. This is the first fundamental theorem of calculus. Okay. So let's just say if I integrate x cubed minus x to the 4 dx between 1 to 2. Okay, so just make sure that you guys know how to do simple math. And also, if you have the situation, usually the easiest way is to look at the common denominator first before you do the rest of the part. So if you integrate this x cubed, it's going to be x4 over 4 minus x5 over 5, right? Between 2 to 1. Is that okay? And then I will plug in 2 to the 4 over 4 minus 2 to the 5 over 5 minus 1 over 4 minus 1 over 5. So usually, like this one's integer. I know it's integer, but usually I combine all the 4 first. So in this case, I'll combine this. So it'll be 16, so it'll be 15 over 4. Is that okay? Because 1 is 16 over 4 minus 1 over 4. And the other one, I'm going to have the negative 32 over 5 plus 1 over 5. Is that okay? Because 2 negative sign, so it'll be plus 1 over, plus, it's going to be minus 31 over 5. It's a plus?
It's minus.
Yes, minus.
Because the first one.
And then now I will combine fraction this way because I have those common denominator I subtract off. I feel like it's usually faster. So I will do the common denominator, even though it's on the 2 separate side of parentheses, I will take it those. Now I can combine this, so I can multiply this by 5 over 5 over 4. So that's equal to 20 of 75 minus 124. Is that right? So that is going to be negative 49 over 20. Now, why is that negative? Because most of part of the graph is probably below x-axis, and that's why it's negative. So if you don't believe me, let's check it out. X to the 4, right? Minus x to the third. Fifth. What? It's like that's right.
Yeah.
But you see between 1 to 2 is all negative. So you can actually integration this. Now, if you use your calculator, please understand this is a 1 to 2. But you do need a parenthesis here when you do an evaluation. X to the cube minus x to the fourth. And you had to put parenthesis dx here. You're gonna be negative 2.75, negative 49/20. So we got it right.
Wait, Mr. Yang, did we have that book last year in the museum? Yeah. We did? Yeah. Yeah. That's crazy. No, I mean, calculated section, yeah.
Is this okay?
Yeah. I just want to know how to type it in. Just type INT.
You had to put a int. You had to type a parenthesis though before.
Yeah, because you know how to put you need to go and put parentheses to that. So that it's basically the dx stays.
Okay, any question about this part? Okay, let's talk about second fundamental theorem. The second fundamental theorem is gonna look like this.
Isn't it the derivative of integral is?
Oh, I do remember that.
Yeah.
Oh, the derivative of integral is like
I
f
remember that one.
prime something.
Okay, FTC part 2. What'd you get?
90 degrees. This is A, this is B. Hey, bro. 4 periods. How much does that kid take?
No, for period. You take 2 days, sir.
No, I thought that day I was right. You told me good job the other day, and I was like, okay, I did it.
I didn't say good job.
I did. Bro,
Are you on crack?
Yeah,
I point out your mistake. I say this
And then,
angle.
when
Why
I
is this
come back-
angle larger
When
than
I
this
come
angle?
back, then I'm leaving. I just come back to say bye. I just see a big circle, and I was like, why? Again, I was like, since they were like, why is it more than like 45 degrees? Once they added it.
Alright, buddy.
You want to see that guy's solution now?
Bro, I keep no, because that would piss me off. Took me 4 periods.
talking about that.
Has a lot to do with pre-calc. though.
No, the kid. He's talking about.
The kid. Hey, he did it with a complex number. All right. So if I ever take a derivative of integration between a to b or a to x, remember this is x. Okay, this is x here. Of f of x dx is equal to f of x, and you're like, wait, if I take an integral of f of x, that should be, the big f of x. So I'm gonna do a slow motion to show you. Slow motion is if I ever take a derivative of this, what I'm gonna get is it's gonna be capital F of x minus capital F of a. Does that make sense? Because the upper bound subtract lower bound. Aiden, is that okay? Zephyr, is this okay?
Yes.
Now I'm gonna take a derivative of this, but there's 2 layers. There's a first layer and there's a second layer. So if you take a derivative of the capital F, so it becomes non-capital F, and then times derivative of the inside, which is 1, minus f of a times derivative a is 0. So that's why you go to f of x. Now, the problem is the boundary does not happen to be x and a. It could be something else. It could be x and e to the x or x squared, whatever, right? So then I'm going to give you a question. The question last period, I didn't do a good job. So anyway, this is sine of x. This is cosine of x. Square root of 1 minus t squared dt. And is equal to f of x. And I say, hey, can you find, do you remember this one question I give you last year several times? And I said, is what? Traumatizing? Not that bad.
Okay, I have a question. What's the Chinese Wi-Fi connection? I know in pre-calc, not with you, but with Mr. Ollie, we learned that if like the first variable in the front has like an odd exponent, you can tell that the function is odd. No,
Not entirely sure.
not entirely.
I can prove that very easily. So Jenny, the function that you can probably like x squared minus x4 over x to the third. What do you think this is even odd?
Is it neither?
It's actually odd.
Don't you first divide it?
No, you plug in negative x. So you plug in negative x to the second power, negative x to the fourth power. That go back to before, right? But negative x to the third. So that's going to be x squared minus x to the fourth over negative x to the third. So it's the opposite original function. It's not always the first thing. It's a function can, there's no such a thing as always. Like, yeah, maybe like, I don't know. It's possible. It should be one, but the idea is so Aiden and Sepper, both of you guys need to know. So the things about this is if every time that boundary has an expression, not a number. If it's a number, just definite integral. Fairly easy. One subtract the other one. If any one of this boundary is a expression, not a constant, then usually they will ask you the derivative of it. So if that ever show, let's just say, hey, in order to take f of x to get f prime of x, I must take a derivative. Does that make sense? So I must d to the dx of f of x is equal to f of x, which is d to the dx of integration of sine of x cosine of x square root 1 minus t squared dt. Now, the whole idea is I don't want to be able to take integral of these functions. I don't care about what this function is. This function just a function. Because if I'm going to take an integral and I'm going to take an I'm going to take an antiderivative first and then take a derivative, I should go back to before. However, there's something that's changing. So you have to be cautious. So we're going to assume this is a different function. We're going to assume that's g of t. Is that okay? So it'll be integration of cosine of x, sine of x, d to the dx, and we say this is g of t dt. Because we can say assume, I think last year everybody don't get this part. G of t is equal to square root 1 minus t squared. Now, on this side, derivative of this is going to be f prime of x, which is exactly what we're looking for. But when you assume like this, that if you integrate this, it's going to be d to the dx of capital G of sine of x, right? Minus capital G of cosine of x. Is that okay? Aiden, is that okay? If I integrate a smaller version of Mario, I'm gonna get the bigger version of volume, which is capital G. We went lowercase g to capital G. I just plug in the boundaries. Then I'm gonna take a derivative of that afterwards. So if I take a derivative of this afterward, it's gonna be lowercase. Like once you get hit by a, what's that thing? The Goomba? You hit by a turtle or Goomba, you start shrinking back, right? So that'll be g of sine of x. But there's two layers though. So that's gonna be cosine of x. And this is the g of cosine of x times the negative sine of x. Now we can go back to plug in this though. So it'll be square root of 1 minus sine square of x times cosine of x minus square root of 1 minus cosine square of x times sine of x. But this one's going to become positive. So we know that's integration of cosine square of x times cosine of x. And this one is going to be sine square of x times sine of x. So that's equal to cosine square of x plus sine square of x is actually equal to 1. So the answer is equal to 1. Huh? What do you have?
I debate, and we have a subject.
Oh, I'm teaching. I'm teaching.
Oh, you're
And
teaching
not
it?
they are going to pepperoni. If they are going to pepperoni, we can play. Yes, 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 yes.
Find out one. Isn't your first variable still gonna be like x to the 1? Isn't that still odd though?
Which one?
The example. If you divide this one, it's gonna be x to the 1.
Yeah, but what if the bottom is the absolute value x? Then that's going to be completely changed because absolute value change is going to be always positive. So you actually be even functions. So you can, there's no always, like, that's saying like Mr. Ye is always smart, but that's not true. It's idiotic all the time.
I like that example.
It's, you cannot say always. Always is a very scary statement.
Just in the context of what we learned in pre-calc, it was.
Yeah, but at that level, yeah, it's like not as difficult. Like, yeah, but so is water is always like it's always like a milk. Is water always boil at 100? So is water always boil at 100 degrees Celsius? Is it? No, why not?
Because pressure.
Pressure. So if you boil your water in like Mount Everest, then it's gonna take a much lower temperature to boil because it has a higher pressure. So it's really hard to say always statement. That's a very scary thing.
Okay, so like I was a kid, I wanted to